Robots aren't just getting smarter, they're becoming shockingly human. XPENG unveiled a female iron robot, so lifelike people thought a real woman was walking on stage. Right after that, Tesla revealed Optimus Gen 3 moving with a level of control that looks less like robotics and more like biology. Meanwhile, Unitree pushed the boundaries again. The G1 you've seen doing flips and kung fu suddenly started playing basketball like a trained athlete. At the same time, 1X Neo, the robot many believed was the next home assistant, got exposed for what's really been happening behind every demo. Hey guys, welcome to Next Gen AI. Today we're talking about the most controversial female robot of 2025. China just unveiled a female robot so realistic, people thought she was human. Meet Iron, the humanoid robot from XPENG, often called the Chinese Tesla. When she walked onto the stage, it wasn't some clunky robot demo. She catwalked like a fashion model, smooth, confident, and perfectly balanced. The audience froze. Many were convinced it had to be a human in a robot suit. When a female robot Iron walked across the stage at XPENG's AI Day event in Guangzhou, something remarkable happened. This robot, with her distinctly female form, moved with a gentle, fluid gait that looked genuinely natural. We're not talking about clunky robot steps here. This was smooth, confident, model-like movement that makes you question everything you thought you knew about the current state of robotics. Even XPENG CEO He Xiaoping admitted that during rehearsals, his own colleagues were asking if there was actually a real human inside the robot. Think about that for a second. The people building this thing weren't even sure what they were looking at. If you saw this robot walk on stage, would you believe it's not human? Be honest, what's your first thought? Share what you think below. Now here's where it gets really interesting. The female robot is so lifelike that people started believing this is a human in a robot suit. And the controversy around this female robot got so intense that XPENG had to do something I've never seen before in robotics. In a live demonstration that felt more like a magic show reveal, the engineering team actually cut away parts of Iron's synthetic skin and padding right there on stage. They literally started removing layers to show what was underneath. And what did they reveal? Complex machinery, articulated joints, robotic limbs, and sophisticated systems driving those fluid movements. Here's the crazy part. Even with sections of her exterior removed, Iron kept walking naturally, demonstrating the genuine engineering behind those movements. If that reveal blew your mind too, hit that subscribe button, because what's coming next will be even crazier. Would you be okay having a humanoid like Iron working in your home or greeting you at a store? Tell me what you'd do in the comments. So what makes Iron so incredibly lifelike? Let me break down the specs. She stands about 5 feet 8 inches tall with perfectly human proportions. That's already a design choice that sets her apart from most humanoid robots, which tend to look more mechanical or neutral. But the real magic is in the movement. Iron has 82 degrees of freedom throughout her body. To put that in perspective, that means 82 different points where she can move independently. Each hand alone has 22 degrees of flexibility. That's what allows her to bend, pivot, gesture, and interact with objects in ways that feel genuinely human. Under the hood, Iron runs on what XPENG calls their VLT brain, which stands for Vision Language Task. This is the core engine that drives her autonomous decision-making. It works alongside 2 other AI models, VLA for Vision Language Action, adapted from XPENG's autonomous driving tech, and VLM for Vision Language Modeling. The whole system runs on 3 custom-built Turing AI chips that pump out a maximum computing power of 2250 TOPS. That's an absolutely staggering amount of processing power packed into a humanoid form. Before we dive deeper, make sure you're subscribed, because next week we're revealing the top 10 female robots of 2025. You don't want to miss it. Alright, back to the video. But here's what really caught my attention. XPENG made a deliberate choice to give Iron a distinctly female appearance, and this wasn't accidental. The company wants to make the robot feel warmer and more intimate for eventual household use. They're even offering customization options where buyers can choose different body shapes, different genders, and different physical characteristics. The CEO compared it to buying a car, saying in the future when you buy a robot, you can choose the gender just like you choose the color of your vehicle. That's a bold strategy that sets XPENG apart from competitors who mostly stick with neutral, genderless designs. Now let me tell you about XPENG itself, because understanding the company makes this whole story even more fascinating. XPENG is one of China's leading electric vehicle manufacturers, often dubbed the Chinese Tesla. They've been making waves in the EV space with smart, tech-forward cars. But here's the twist. Of XPENG's 7 generations of robots, 5 were actually quadrupeds, 4-legged designs. They ultimately pivoted away from that approach, and the CEO's reasoning is really interesting. He argued that a human-like form is crucial for collecting valuable data from humans. His logic? If a robot structure is totally different from humans, you can't collect realistic data that generalizes well to human-centric environments like homes, offices, and shopping malls. Smart move or risky future? XPENG says human-like robots collect better data. I really want to know what you think. Drop it in the comments below. Iron also features some genuinely innovative hardware beyond just the AI brain. XPENG claims she's equipped with the first all-solid-state battery in the robotics industry. That's huge because solid-state batteries are safer, more energy-dense, and longer-lasting than traditional lithium-ion batteries. The CEO defended using this sought-after tech in a robot instead of a car by pointing out that the safety requirements for a device operating in your home are actually more stringent. The robot also has what they call bionic muscles that enable different body shapes and a full-coverage soft skin embedded with touch sensors for more natural interaction. But here comes the reality check. Despite all this incredible technology, XPENG is being surprisingly cautious about deployment. They're targeting mass production preparations starting in April of this year, with full production by the end of 2026. But here's what's fascinating. They're explicitly avoiding the 2 markets everyone assumes humanoid robots are made for. No factory work, because trials showed the complex hands wear out in as little as a month, and it's actually more cost-effective to hire human workers in China. And no household chores yet, primarily due to safety concerns and the massive challenge of navigating cluttered, unstructured home environments. Would you trust a robot that looks and moves exactly like a human? Let's talk about it. Hit the comments and tell me what you think. The crazy part is, XPENG's reveal was only the beginning. Because while Iron stunned audiences with realism, another giant made an even bolder move. Tesla stepped onto the stage with a robot that didn't just look human, it acted human. And what Optimus Gen 3 is doing inside Tesla's factories right now feels like the next chapter of robotics. Elon Musk just revealed Optimus Gen 3 at Tesla's 2025 shareholder meeting, confirming its major upgrades and the official reveal date. This new version isn't just improved, it's a complete redesign built for real-world autonomy. Inside Tesla's production floor, Gen 3 robots are already walking, working, and charging themselves with zero human control. The future Musk promised is no longer coming. It's already here. First off, inside Tesla's production floor, Gen 3 robots are roaming freely, fully autonomous. No cables, no joystick control, no human supervision. They navigate hallways, lift components, and when their battery dips, they casually walk themselves over to a charging dock like it's the most natural thing in the world. It's the kind of scene you'd expect in a sci-fi movie, except it's not CGI. It's real footage coming from Tesla's Fremont facility in 2025. Now, what makes this version such a big deal? Because Gen 3 is the first true leap, not a step, in humanoid design. Everything about it, from the way it moves to the way it thinks, has been rebuilt from the ground up. The frame is lighter, the actuators are more compact, and the balance control is eerily human. Watch it walk, and you'll notice it no longer looks robotic or clunky. Every joint flexes smoothly. Each footstep has micro-adjustments. Every motion has natural weight. Let's rewind for context. The first Optimus prototype back in 2022 was impressive for what it was, a mechanical skeleton showing proof of concept. Then Gen 2 brought controlled movements and basic manipulation. But Gen 3? It's different. This is Tesla's first humanoid that behaves like a living system. Its 50+ degrees of freedom allow human-level fluidity. The redesigned actuators use Tesla's new electromechanical architecture that delivers higher torque with less power draw, meaning smoother motion and longer operation on a single charge. The spine, knees, and hips have been tuned for balance that reacts dynamically. It can now recover from slips or bumps without falling. But the real magic lies in the hands. Tesla engineers call them the most difficult mechanical challenge we've ever faced. Each hand now has articulated fingers with high-precision sensors that detect force, texture, and angle in real time. You've probably seen the viral clip, Optimus carefully picking up an egg and rotating it between its fingertips without cracking the shell. That wasn't staged. It was a live demo. Optimus Gen 3 is now capable of manipulating everyday objects that most robots can't even identify. Folding laundry, stacking items, wiping surfaces, picking up trash, sorting materials, all done autonomously. Tesla's AI team trained these behaviors using the same vision-based neural networks that power autopilot. Would you actually want an Optimus robot in your home? Be honest, helpful assistant or creepy roommate. That means Optimus doesn't rely on pre-programmed paths. It perceives the world around it through cameras, builds a 3D map of its environment, and makes decisions on the fly. It's not reacting, it's reasoning. It understands the difference between a tool and a dish, between something fragile and something heavy. It can generalize actions. If it learns how to pick up one towel, it can handle any towel. That level of generalization is exactly what separates a toy robot from a real worker. Inside Tesla facilities, these robots are now assisting with part handling, simple logistics, and cleaning tasks. They move around staff, detect obstacles, and even mirror human motion for learning tasks. And when they're done, they plug themselves in, literally walking over to their dock and recharging. No human involvement. What's wild is that Gen 3's brain runs on Tesla's unified AI platform, the same system training millions of self-driving cars every day. Every Optimus unit collects data, improves through reinforcement learning, and sends that knowledge back to Tesla's neural network. Essentially, the entire robot fleet learns together. The more they move, the smarter they all get. That's the Tesla effect. Just like autopilot went from 0 to city driving capable in a few years, Optimus is evolving through iteration speed no other robotics company can match. Each update improves walking, dexterity, and problem solving, almost like over-the-air software updates for a human body. Gen 3 also got a full aesthetic redesign. The outer shell is smoother, more organic, and made from lightweight composite materials to reduce weight and improve energy efficiency. The proportions are closer to a fit adult human, around 5 feet 8 inches, 55 kilograms, and capable of carrying 20 kilograms comfortably. The motion control system now allows dynamic balancing, so you can push it slightly, and it recenters itself just like a person would. The cameras, placed in the head and torso, have ultra-wide field vision with depth perception. Combine that with Tesla's neural net inference chip, and you get real-time scene understanding at millisecond latency. It doesn't just see the world, it interprets it. Now here's where things go from exciting to absolutely insane. Tesla is not just building robots, it's industrializing them. The company already has a pilot line in Fremont producing early Gen 3 units, and the ramp plan looks almost impossible. Phase 1, 1 million units per year from Fremont. Phase 2, 10 million units annually from Giga Texas. And long-term, Tesla's global target is hundreds of millions of Optimus units. Let that sink in. Hundreds of millions of humanoids potentially in circulation before 2035. For comparison, humanity produced about 1.5 billion cars in the last century. Tesla wants to surpass that within a few decades with robots. And they're treating this exactly like a car business. Optimus shares over 70% of its supply chain components with Tesla's vehicle ecosystem: sensors, batteries, actuators, chips, meaning the scaling potential is enormous. When Musk said, "This will be the fastest manufacturing ramp of any complex product ever built," he wasn't exaggerating. The economic implications are beyond massive. Each Optimus Gen 3 unit costs roughly $20,000 at scale, the same ballpark as a Toyota Corolla. For that price, you're getting a worker that never sleeps, never gets sick, and never asks for a paycheck. Imagine what that does to global production. Factories could operate 24/7 without overtime. Construction costs could drop by 80 to 90%. Farming, logistics, mining, all could be automated with near-zero human labor. Tesla's term for this vision is sustainable abundance. The idea is simple but radical. When physical work becomes infinitely available and infinitely cheap, the cost of goods collapses. Housing, food, energy, everything could drop to near zero marginal cost. It's the first step toward an economy where basic needs aren't constrained by human labor. Now, this is where things get emotional. Tesla's collaboration with Neuralink could make Gen 3 not just an autonomous worker, but a full-body extension for humans. We've already seen Neuralink allow a paralyzed person to control a computer cursor with thought alone. The next milestone is giving someone full-body motion using an Optimus frame. Imagine a person who's been unable to walk for years suddenly standing, running, or dancing again, not in virtual reality, but in the real world, through a robotic body they control with their brain. The feedback system would even transmit sensation, texture, pressure, maybe even warmth. For people with severe disabilities, that's not science fiction. It's hope. But the same tech raises profound questions. What happens when a human consciousness can effectively live through a robot body? Where does the boundary between mind and machine end? Tesla calls it symbiosis. Critics call it digital reincarnation. Either way, it's coming faster than anyone expected. Of course, it's not all smooth sailing. The biggest engineering obstacle remains the hand. Recreating the precision and control of 27 bones and 34 muscles in a lightweight electromechanical system is brutally hard. Each movement requires micro-level torque control, instant feedback, and fine motor algorithms that can adjust in milliseconds. Then there's perception. Real-world environments are chaotic, reflections, fabric folds, lighting shifts, unpredictable human movement. Training an AI that can adapt safely in that chaos is an enormous challenge. Tesla's solution is to feed the robots massive amounts of real-world data through simulated environments powered by the Dojo supercomputer. But even then, the gap between lab and life is tricky. Manufacturing at scale is another mountain. No one's ever built millions of humanoid robots before. The actuator supply chain, high-density batteries, heat management systems, all need to be designed from scratch. Tesla is essentially inventing a new industry in real time. Here's what's next. The version Tesla showed at the 2025 shareholder meeting is Optimus 2.5, the final prototype before Gen 3 goes into full production in 2026. After that, Tesla plans annual upgrades, Gen 4 in 2027, Gen 5 in 2028, and so on. Each one lighter, smarter, faster, and more efficient. That pace mirrors the smartphone industry. Just like we went from flip phones to facial recognition in a decade, humanoids will go from factory assistants to fully capable personal helpers by 2030. The robot in your living room will evolve faster than any consumer technology in history. Here's the kicker. This isn't just a passion project. It's tied directly to Tesla's long-term business incentives. The company's CEO Performance Award for 2025 includes milestones like deploying 1 million Optimus units by 2035. If Tesla hits them, Musk's payout could exceed $1 trillion. Over 75% of shareholders already approved it. That means every executive, every engineer, every dollar in R&D is aligned toward mass-producing humanoids. This isn't hype, it's strategy. Tesla is betting its entire future on automation, betting that Optimus will one day generate more revenue than all their vehicles combined. And with a projected price of $20,000 per unit and demand from both households and industries, that's not unrealistic. Think about where this goes. Factories with no lights because robots don't need them. Construction sites running 24/7. Hospitals using humanoids as physical assistants. Families owning personal robots that cook, clean, and lift heavy objects. Within a decade, these machines could be as common as washing machines. Do you think Tesla's humanoid robots will really replace human workers? Or will they just create new kinds of jobs? I'm curious where you stand on this. And just when you think Tesla set the limit for what humanoids can do, another breakthrough arrives from a completely different direction. Because Unitree didn't focus on household skills or factory tasks, they aimed straight at athletic control. Their G1 robot didn't just move smoothly. It mastered a sport built on timing, balance, and instinct. This next part shocked every engineer watching. We've all seen the Unitree G1 do wild things before. backflips, sprint bursts, martial arts sequences that look shockingly clean for a 35-kilogram robot. But basketball, that's a whole different level. Up until now, every G1 demo was basically the robot controlling its own body. Just movement, jump, flip, kick, balance, but all self-contained. Basketball changes the entire game, because now the robot has to control another object. And that object isn't predictable. It's round, it bounces, it slips, it rotates, and it reacts to force in real time. So suddenly, the robot needs a brand new set of skills. It has to grip the ball without crushing it. It has to calculate the shot based on the exact position of the hoop. It has to manage gravity, distance, angle, and release timing. And while doing that, it has to adjust its own body position based on what the cameras are seeing, frame by frame. And here's the wild part. All of this has to happen at the exact same moment. No pause, no hesitation. No, let me recalculate for a second. Just one continuous flow of vision and motion planning operating at full speed. But the part that surprised everyone is this. The G1 isn't taking random shots. It's actually copying signature NBA moves. LeBron's single-leg silencer celebration. Kobe's fadeaway jumper. These moves are hard even for trained athletes. You need rock-solid balance on one leg. You need perfect timing between your upper body and lower body, and a clean release angle under pressure. Humans take years to master these mechanics. This robot learned them in months. Do you think the G1's basketball skills are real progress, or just a flashy demo? Let me know in the comments. Behind all of this is a new framework called ASAP, a system that teaches the robot real basketball skills by aligning simulation with real-world physics. It's the secret sauce that makes these shots look almost human. The workflow is pretty simple, but incredibly effective. Researchers collect motion data from actual basketball players. Real jumps, real shots, real footwork. They convert that data into a language the robot can understand. Then the G1 practices the moves thousands of times in simulation. Different versions, different corrections, different failures. All of it happens in a safe virtual environment where there's no risk of breaking hardware. Once the robot learns the basics in simulation, it brings those moves into the physical world. And this is where things get interesting, because the G1 fails. A lot. It bends too late. It releases too early. It shifts weight incorrectly. But every single failure creates new data. That data teaches the system how real physics differs from virtual physics. Slowly, the robot closes that gap. What it thinks will happen and what actually happens start to match. And with each iteration, the G1 gets cleaner, smoother, and more accurate. One of the hardest challenges is the grip. The robot's hands automatically adjust pressure depending on how tightly it needs to hold the ball. Too much force, and the ball deforms or slips. Too little, and the ball pops out mid-motion. So the G1 is constantly making micro-adjustments, tightening, loosening, stabilizing, all while moving through the shot. Now let's talk about shooting mechanics, because this part shows just how advanced the G1 is. A basketball shot has 5 phases. Knee bend for power, upward extension, torso rotation, arm extension, wrist flick, and follow through. All 5 need to connect smoothly. If one phase is early or late, the shot fails. Human players learn to sync these moves instinctively over time. Robots don't have that luxury. So the G1 has to compute every tiny movement, and it has to keep its balance while doing it. When you shoot a basketball, your center of mass shifts in multiple directions. Forward, upward, sideways. The G1 constantly senses those shifts and adjusts its stance instantly to stay stable. And after watching this whole basketball demo, you'd think this was Unitree's biggest update. But actually it wasn't. If you're loving these humanoid robot updates, make sure to subscribe. We're just getting started. Unitree showed how far pure control can go, but the next story exposes the reality behind home robots today. Because while some machines look advanced on camera, their intelligence comes from somewhere unexpected. And that's exactly where 1X Neo enters the conversation, pulling back the curtain on how humanoids really learn. What you're about to see is the part most companies never talk about. 1X recently opened pre-orders for the Neo humanoid robot, and on the surface, it looks like the beginning of a new chapter in home robotics. A simple white suit, calm movements, and a design that feels more like a quiet assistant than a sci-fi machine. Neo is priced at $20,000 or $500 a month after a small deposit. And the promise is straightforward, a home robot that can help with basic tasks. But once you look closer, the picture changes quickly, because Neo isn't fully autonomous yet. In fact, most of what was shown in the demos had something else happening behind the scenes, something that 1X calls expert mode. This is the part that defines the entire product. Neo has 3 operating modes, and expert mode is the one that takes over when the robot doesn't know how to perform a task. Instead of relying on onboard intelligence, a human operator, anywhere in the world, puts on a VR headset and directly controls the robot's body. The operator moves their hands. Neo moves its hands. They turn their head. Neo turns its head. It's a full teleoperation link designed to help the robot collect training data. And here's where things get interesting. In independent demos, including one done by the Wall Street Journal, every single task was performed through expert mode. Not a few, all of them. The only autonomous action confirmed so far is something very simple, like grabbing a bottle. Anything more complex is still handled by a human. This doesn't make Neo a bad robot, but it makes the robot very different from what many expected. The autonomy that has been implied is still early stage. What Neo is today is a teleoperated robot that uses human demonstrations as training material. And early buyers are playing a direct role in that learning process. But the moment you introduce teleoperation, you introduce a second layer, privacy. For expert mode to function, Neo streams live video to 1X so operators can see what the robot sees. That means the robot's cameras become a window into your home. This raises obvious questions. Who sees the footage? What gets recorded? And how much control does the owner actually have? 1X has put guardrails in place. The app allows you to mark private rooms as no-go zones. Human faces can be blurred automatically, and expert mode only activates when the user approves it. These controls help, but they don't change the fundamental requirement. Neo's learning depends on a human operator watching through the robot's cameras. Do you think teleoperated robots are a smart stepping stone, or should companies wait until full autonomy is ready? Let us know in the comments, and when you zoom out, something becomes clear. Neo isn't an exception, it's an example of where the entire robotics industry actually is right now. No humanoid robot today can operate independently inside a real home. Not Tesla Optimus, not Figure, not Unitree. Every major robotics company uses teleoperation or guided control during training. Tesla uses motion capture suits behind the scenes. Sanctuary's Phoenix robot learned through months of human demonstrations. Figure AI prefers factory tests over unpredictable homes. Even the most polished Chinese prototypes still rely on guidance during complex maneuvers. The technology is advancing fast, but none of these systems are ready for full home autonomy. So why sell robots this early? Because the companies building them need real-world data. And real-world data only comes from real homes. Every time Neo gets stuck and a human takes over, the robot collects video, movement, and decision patterns. Over time, these examples become the training material the AI uses to learn how to perform the same tasks independently. It's the same strategy self-driving cars used in their early days. Humans drive. The system watches. The AI slowly learns. From a development standpoint, it accelerates progress. From a customer standpoint, it means you're buying a robot that is not fully ready yet. Neo represents the transition era of humanoid robotics, the phase between controlled lab demos and true home autonomy, a stage where robots still require human help, But that human help becomes part of the training pipeline for the future. So the real question becomes simple. Are we ready for a robot that still depends on a human operator? Even if that dependency helps the AI learn faster? We all know Boston Dynamics Atlas. Atlas shocked the world with moves people didn't think a robot could survive. For years, Atlas held the top spot as the world's most athletic humanoid. The benchmark every new humanoid had to match before daring to brag. But today, things just changed. Because two new robots from China just stepped into the spotlight. And together, they make Atlas look like it's suddenly a step behind the cutting edge. One of them looks like the softer, friendlier version of Atlas we never got. And the other? It launches into a backflip with the kind of power you'd expect from a trained gymnast. Meet PHYBOT C1. At a glance, you'd swear you're looking at the new electric Atlas. Same sleek frame, same balanced proportions, that same futuristic silhouette. Except the C1 doesn't look like it belongs in a factory. It looks like it belongs in your living room. Soft body, skin-friendly surfaces, warm breathing lights that pulse like it's alive. A robot meant to stand next to you, not tower over you. This thing was designed to make people feel safe. It's cute, friendly, and almost too human in the way it moves. And it does it all with the calm vibe of a robotic companion that actually understands emotion. But don't get too comfortable, because PHYBOT didn't stop at friendly robot. Their second machine is built for pure chaos, in a good way. This is the M1, and it's the one that's making engineers everywhere stop what they're doing. Imagine a robot that looks like it was engineered to punch gravity in the face. A robot that winds up, jumps, rotates midair, and lands like a gymnast sticking a perfect routine. No cables, no hydraulics, no tricks, just raw electric power exploding through its legs. The first time you watch the clip, your brain goes, wait, did an electric humanoid really just do that? And yes, it did. The M1 doesn't just flip. It launches. It jumps like a human athlete. And it lands so smoothly that you almost forget there's no pilot inside. But here's the crazy part. This flip isn't even the point. PHYBOT isn't trying to show off. They're trying to say, we built a robot so strong, so stable, and so balanced that it can do a backflip without breaking a sweat. And when you look closer, you realize they're not joking. The M1 was built for real work, carrying heavy loads, helping in construction, assisting in manufacturing, maybe even doing search and rescue in dangerous places. This isn't a stunt robot. This is a worker with legs that hit like a coiled spring. When it jumps, you feel the power just by watching it. And that's the moment things shift. Because suddenly, Atlas, the robot we all thought was untouchable, starts looking a little old school. But PHYBOT built something different. Something cleaner. Something electric. Something that doesn't sound like a machine exhaling steam every time it moves. The M1 moves more like a human athlete than a giant industrial machine. And it doesn't just match Atlas energy, it challenges it. Meanwhile, the C1 is quietly doing something Atlas never tried to do. Be lovable. If Atlas looks like the world's strongest parkour athlete, the C1 looks like your friendly neighbor who always helps you carry groceries. When you stand next to it, you don't feel like you're next to a robot built for warehouses. You feel like you're next to a robotic buddy, a helper that can talk, listen, guide, remind, and interact like a digital companion wrapped in a humanoid body. And the wild part? It still looks like Atlas, just nicer. Which one actually impressed you more, the friendly C1 or the explosive M1? Tell me what you think in the comments. But here's the real twist. These two robots aren't competing with each other. They're completing each other. PHYBOT basically split Atlas into two separate machines. One robot that's all heart, another robot that's all muscle. C1 handles the social side, M1 handles the physical side. And together, these two robots cover everything Atlas was famous for, but each one does its category even better. Think about it. Atlas does flips. M1 does a clean, controlled, fully electric flip that looks almost too smooth to be real. Atlas has power. M1 has explosive leg strength paired with stable electric movement that feels like an athlete wearing robotic armor. Atlas can lift heavy stuff. M1 can do real tasks too, but with electric silence and better balance. And Atlas? It was never made to stand in a mall and talk to kids, guide tourists through a museum, or give emotional feedback. That's where C1 shines. It moves softly, talks naturally, reads emotions through its sensors, and even uses breathing-style lighting to show how it feels. Before we jump into the next part, take a moment and subscribe to NextGen AI. Okay, let's get back in. But wait, here's the craziest part of all. The secret behind PHYBOT's robots isn't the flipping, or the cuteness, or even the power. It's the joints. PHYBOT uses a special kind of joint system that behaves like robotic muscle. These joints absorb shock when the robot lands. They stay smooth even under heavy force. They're strong but flexible, stable but fast. It's like giving the robot reinforced knees, shoulders, and hips that never jam, never rattle, and never skip. And this is what lets M1 explode upward into a jump without losing balance. This is what lets C1 move softly without feeling robotic. This is why PHYBOT can confidently say their robots are built for real use, not just demo videos. If you could have one of these robots at home, which would you choose? I love reading your comments, so share your thoughts. China has officially put a humanoid robot traffic cop on the streets. Not for testing, not for show, but for real duty. On top of that, the team behind the robot dog showcased in the military parade has unveiled Sky Wolf, a robotic wolf born directly from military tech. Meanwhile, UB Tech is pushing Walker S2 humanoids into full mass production. China just unleashed a new humanoid robot, not in a lab, but on the streets, as an actual traffic cop. Yeah, you heard that right. This isn't some demo clip at the Shanghai China International Import Expo. The Fourier Intelligence GR2 robot was deployed as a working officer at busy intersections, waving cars to stop, signaling pedestrians to cross, and managing the chaos of city traffic in the middle of everything. Under the shell, the GR2 uses AI-driven computer vision and path planning to interpret traffic density in real time. It tracks flows of vehicles, reacts when something suddenly blocks the road, and updates its signals on the fly. If a crowd suddenly surges onto the crosswalk or a car tries to jump the light, the robot adjusts, just like a trained officer would. On top of that, the battery isn't just a weak demo pack. GR2 can operate for up to 2 hours on a single charge before a quick battery swap, which means it can work in shifts, just like a human team rotating positions. But what makes this deployment so important isn't just the cool visuals. It's the category of job it's doing. Fourier is proving that humanoid robots can handle complex, unstructured environments in public spaces. We're not talking about stacking boxes in a warehouse or tightening the same screw 10,000 times a day. We're talking about dynamic public service work, surrounded by humans who don't care they're part of a robotics experiment. Even more interesting, GR2 is built for customization. It supports developer tools like ROS and NVIDIA Isaac, which means cities could adapt the same platform for different roles. Today it's a traffic cop. Tomorrow it could be a crowd control assistant at festivals, a guide at train stations, or an emergency responder that rushes ahead to assess accidents before human teams arrive. The gap between robot in simulation and robot in your daily commute just got a lot smaller. And China chose traffic control, one of the most human, visible, and high-stakes jobs in a city, as the test case. If a robot can stand in the middle of an intersection and keep humans from crashing into each other, what else can it do? What do you think about this? Would you trust a humanoid robot directing traffic in your city? Let me know in the comments. I'm really curious where you stand on this. Now, while GR2 is taking over the streets, China has another robotic surprise coming from the military side. The team behind the robotic wolf that marched in China's Victory Day military parade, 58 Intelligence Technology, just made its next big move. They've unveiled a new quadruped robot called Skywolf. But here's the twist. This time, the main target isn't the military. It's business and industry. Skywolf takes the same core strengths that made the original Parade robots so impressive: high mobility, strong terrain handling, and AI-based autonomy, and points them at real-world jobs. Think search and rescue in disaster zones, security patrols around large facilities, logistics in tough terrain, and inspection in hazardous areas where humans shouldn't be walking around. And that move is already paying off, because they've secured major funding to scale Skywolf into a real product, not just a parade moment. They've raised 500 million Chinese yuan, around $69.4 million USD. It gives 58 Intelligence the fuel to scale manufacturing, improve hardware, and upgrade its AI stack so Skywolf can compete with global players like Unitree, Ghost Robotics, and Boston Dynamics. And the message is loud. China isn't just building robots for parades and propaganda. It's commercializing them. What's your take on Skywolf stepping into real-world jobs? Cool upgrade, or a little too close to sci-fi for comfort? Drop your thoughts below. We've seen robots on the streets. We've seen a robot wolf stepping out of the military world. Now let's look at something that honestly feels like a shot straight from a sci-fi movie: a humanoid robot assembly line. China has been quietly entering a new era of robotics. Full-scale, mass production of humanoid workers. UB Tech just rolled out its first wave of Walker S2 robots, and the visuals are insane. Rows of tall humanoids lined up in factories, white shells, smooth joints, all waiting to be deployed to real industrial sites. This isn't some limited edition prototype run. This is mass manufacturing that kicked in around mid-November 2025. Walker S2 is built like a serious industrial teammate. It comes with an autonomous battery swapping system. The robot can dock itself, eject a drained battery, slot in a fresh one, and go straight back to work without a human lifting a finger. That's 24/7 operation with almost no downtime. Its whole body dynamic balance system lets it tilt up to around 170 degrees without falling over, carry payloads in the 15 kilograms range, and weave through crowded factory floors with a gait that looks surprisingly natural. It's not shuffling like an old-school bot. It moves like a careful human worker navigating between shelves, machines, and people. Fine motor grippers in the hands let it handle delicate objects, not just heavy boxes. And under the hood, Walker S2 runs on powerful AI chips that fuse vision, touch, and sensor feedback in real time. That means it's not just replaying pre-programmed motions. It's responding to the environment moment by moment. If you love staying ahead of the AI and robotics curve, hit subscribe. I drop these deep dives every day. So what does this all add up to? On one side, you have Fourier's GR2 standing in the middle of a live intersection, proving that humanoids can handle messy, unstructured human environments. On another side, Skywolf is taking military-grade mobility and repackaging it as a flexible tool for rescue, security, and industrial work. And behind the scenes, UB Tech's Walker S2 army is quietly rolling off production lines, ready to replace or augment human labor in factories across China. Street-level robots, enterprise-grade quadrupeds, factory-built humanoid armies, all emerging at the same time in the same country. This is the part that matters. We're moving past the era where robots are just viral clips or tech demos. China, especially, is treating them like infrastructure, tools you plug into cities, supply chains, and industrial systems. Today it's a robot directing traffic for 2 hours at a time. Tomorrow it might be a squad of walkers patrolling a factory, while a Skywolf inspects a dangerous pipeline, and a humanoid greeter helps people navigate a train station. And when that world arrives, it won't feel like a sudden sci-fi jump. It'll feel like this week, just scaled up. So when you hear, China just launched its first real robot traffic cop, remember, it's not just one robot. It's a signal. The streets, the factories, and even the spaces between them are slowly being handed over to machines. The only real question is, how long until you pull up at a red light and it's a robot waving you to stop? So what do you think? Are robot traffic cops, robot wolves, and humanoid factory workers the future you expected? Or is this all moving a little too fast? Share your thoughts in the comments. Unitree has introduced something called the Embodied Avatar platform, and it's easily one of the most significant breakthroughs we've seen this year. In simple terms, this system allows a humanoid robot to move exactly as a human does at full natural speed, in real time, with no video tricks or slow motion edits. That's not a small improvement. That's a complete redefinition of teleoperation. Companies often slowed down operators or sped up footage to hide lag. But this time, what you see is what's actually happening. The G1 moves as fast as the human controlling it, with no delay, no waiting, no faked cuts. And that's why this moment matters more than most people realize. So what exactly is Unitree showing? It's a full-body teleoperation system that mirrors every single human movement: head, arms, legs, torso, all tracked through a simple lightweight motion capture suit. When the operator walks, the robot walks. When they twist, kick, or bend, the G1 does the same instantly. There's no half-second pause, no slow motion lag, just fluid motion that feels alive. And that's the part most companies have never managed to solve, eliminating latency while keeping movement natural. Latency is what's always broken teleoperation. Even a small delay turns a robot into a clumsy puppet. Try reacting to a falling object with a half-second delay, you can't. Everything feels unnatural. That's why so many real-time robot demos you've seen online weren't actually real-time. They were edited to look perfect. Unitree, on the other hand, explicitly stated there's no speed-up in their video. What you're seeing is live motion, human reflexes projected straight into a humanoid form. The difference becomes obvious when you look at what the G1 is doing. In the demo, the operator plays soccer while the robot mirrors every move, juggling, kicking, adjusting balance, all at real-world speed. Two G1s spar in a boxing sequence that looks less like choreography and more like an actual fight, complete with footwork and quick reactions. Then you see martial arts drills with a staff, each swing and pivot happening as naturally as a trained athlete's. These aren't cinematic rehearsals. They're raw teleoperated movements, recorded without any time distortion, and that's what makes them so powerful to watch. But Unitree didn't stop with athletic showcases. They also demonstrated how this tech translates into everyday tasks, things like cleaning tables, loading dishes, vacuuming, or putting items into a fridge. The G1 opens a trash bin with its leg while holding a can, tosses it in smoothly, and moves on to the next task, all at human pace. Would you trust a humanoid robot like this to clean your home or serve you food at full speed? That natural timing is everything. When a robot has lag, even small actions become awkward. But when it moves at real-world speed, it suddenly feels capable, useful, and efficient. Here's where the real genius comes in. Unitree isn't only creating a control system, they're creating a data engine. Every time an operator performs a task through the G1, every gesture, reaction, and timing pattern is recorded. That means each teleoperated session becomes a training dataset for future autonomous AI models. It's called full-body data acquisition, and it's the bridge between remote control and full autonomy. Robots aren't just copying humans anymore, they're learning from them in motion at authentic speed. This is what sets Unitree apart from companies that only focus on demos. Slow data creates slow robots. If you record movements at half speed, you train AI to move sluggishly. But when you record natural human speed motion, the AI learns real-time dynamics, when to lift, when to balance, when to accelerate or stop. That's the kind of data that leads to robots capable of matching human rhythm and reaction in daily environments. The motion capture setup itself is surprisingly minimal, just straps and sensors. No bulky frames, no dozens of cameras surrounding the room. That simplicity lets the operator move freely, which in turn makes the robot's motion more fluid. And because the entire system is built around efficiency, it's also affordable. At roughly $16,000 for the G1, Unitree is targeting scalability, not just one-off research projects, but real deployment. Do you think robots learning directly from human movement will make them more useful or too powerful? Now think about why that matters economically. A robot that's fast but expensive is unsustainable. A robot that's affordable but too slow is useless. But a robot that can perform tasks at human speed, costs less than a small car, and gathers its own AI training data, that's a business model that can actually evolve in the real world. You can use teleoperated robots for productive work today, while they simultaneously gather the experience to operate autonomously tomorrow. That's immediate value and long-term payoff in the same system. Unitree's leadership has been repeating a simple message: robots that work, not just robots that look impressive. And this platform captures that idea perfectly. It's practical, it's scalable, and it delivers results at the pace the real world demands. No waiting years for future AI upgrades. This is usable technology right now. What also stands out is the transparency. Unitree doesn't rely on cinematic edits or flashy cuts. They show the full unedited footage with no video speedup stated clearly. That kind of honesty is rare in robotics, where marketing often hides the limitations. By revealing true, unfiltered performance, they're setting a new benchmark for credibility, one that other companies will now have to meet. The implications are enormous. If robots can finally operate at human speed, they can integrate into actual work environments, homes, factories, restaurants, hospitals, without slowing things down. Every industry that depends on timing and coordination suddenly becomes open to humanoid assistance. And this is just the beginning. Because once you combine real-time teleoperation with AI that learns from that data, you move toward a future where robots won't just follow humans, they'll start anticipating and cooperating with them naturally. So yes, the Embodied Avatar platform is much more than a flashy showcase. It's a proof of concept for a coming shift where human skill and AI intelligence merge through motion. And for the first time, we're watching that merge happen at full human speed. And this breakthrough doesn't exist in isolation. It's part of a much bigger ecosystem Unitree has been quietly building. The G1 and its embodied avatar system are just one piece of a broader vision that now includes the H2 and R1 humanoids, robots designed to push that same technology into new domains. The Unitree H2, revealed just months ago, is a larger, more powerful humanoid belt for industrial and service applications. It's equipped with stronger joint actuators, higher torque outputs, and an upgraded balance system that allows more dynamic movement, climbing, lifting, and performing heavy-duty tasks that go beyond what the G1 can handle. Think of it as the next evolutionary step, combining raw physical capability with the same teleoperation precision demonstrated in the G1. Once the Embodied Avatar platform expands to H2, you're talking about a robot that can operate at factory scale with human responsiveness. Then there's the R1, Unitree's lighter, more consumer-friendly humanoid aimed at education, assistance, and daily use environments. It carries the same design language as its larger siblings, but with simplified mechanics and a lower-cost target, potentially bringing human-speed robotics into schools, research labs, and even private homes. Together, the G1, H2, and R1 form a complete hierarchy. Data collected from human-speed teleoperation today could soon be shared across this entire family of robots, accelerating the path toward autonomy for every model. Pixar-style robots are no longer just movie characters. They're quietly rolling into real homes, doing real tasks, and showing a kind of warmth and personality that feels straight out of an animated film. Sunday Robotics unveiled Memo, a soft, calm home robot that moves with the gentle confidence of a movie companion. Tangible Robotics introduced Eggy, a small round robot with human-like hands and a curious way of interacting with the world. And based on how these robots look and move, it's easy to imagine kids instantly gravitating toward them. Not because they're made for children, but because their design mirrors the friendly, soft robots we've grown up seeing in stories like Big Hero 6 and The Wild Robot. For years, Most robots had a very different look. Metal frames, exposed joints, stiff movements, and a posture that made sense in a lab or factory, but not in a home. They were strong and precise, but they felt cold and distant. Now, a new kind of robot is emerging robots with soft curves, gentle motions, and designs made for everyday spaces like kitchens, bedrooms, and living rooms. Robots that look less like machines and more like characters. Sunday Robotics introduced Memo, a home robot that feels like a Pixar character brought to life. The first thing that stands out is the shape. A clean white body, smooth edges, a gentle digital face, a sliding torso that gives Memo an organic silhouette. Nothing sharp, nothing industrial, nothing that signals danger or mechanical aggression. Memo looks like a robot designed for comfort, something that belongs in the same world as Baymax, built to coexist with humans, not overpower them. But Memo's design is only the beginning. What truly sets it apart is the way it interacts with the world. When Memo walks up to a messy dinner table, its movements look careful and deliberate. It picks up plates, balances wine glasses, separates food waste, loads the dishwasher, and starts the wash cycle, all with calm, measured motions that feel more intentional than mechanical. Memo then turns to a pile of laundry, organizes socks, smooths fabric, rolls each pair neatly, and places them into a basket with surprising accuracy. These aren't flashy stunts. They're relatable, real-world tasks performed with a softness that feels almost animated. There's also the espresso moment. Memo twists a portafilter with real force, locks it in place, runs a shot, and gently places the cup down. This blend of strength and delicacy is something viewers instantly connect to, not because it's technically impressive, but because it resembles the human behaviors we see in everyday life. If you're enjoying these deep dives into the future of robotics, make sure to subscribe. More real breakthroughs are on the way. Behind these movements lies one of the most innovative training systems in robotics. Instead of relying on expensive teleoperation rigs or one-on-one human control, Sunday Robotics developed a skill glove that matches Memo's hand shape and sensor structure. Humans wear this glove in their own homes while performing natural everyday actions, washing dishes, organizing shelves, wiping counters, folding clothes. The glove captures every micro-movement, grip pressure, finger positions, torque, adjustments, and interactions with objects of all shapes and materials. Because the glove is shaped like Memo's hand, the data translates directly into robot-ready demonstrations. That means Memo learns from human behavior without needing to be physically present in each environment. To refine this further, Sunday built a system called Skill Transform, a model that converts human demonstrations into Memo's geometry, style, and motion capabilities. The robot doesn't just copy human movement. It learns how Memo would perform that same action in a robot-optimized way. All of this feeds into Sunday's foundation model, ACT. 1. The intelligence layer that handles movement, navigation, manipulation, and long-horizon planning. With ACT, 1. Memo can step into an unfamiliar home, map the space, understand object relationships, and perform tasks in real time based on goals instead of scripts. It's not following rigid routines. It's interpreting the world and making decisions. Do you think simpler hands with smarter software is the right direction for home robots? Share your thoughts below. Your ideas help shape future episodes, but Memo isn't the only Pixar-like robot emerging right now. Tangible Robotics introduced Eggy, a small, rounded robot that moves with curiosity and confidence. Eggy doesn't look like a traditional machine either. With its friendly wheels, soft outer shell, and full human-like hands, it resembles the kind of character an animator might design if asked to imagine a robot that lives in a kitchen or home. Where Memo emphasizes calm usefulness, Eggy emphasizes touch. Tangible Robotics believes touch is the missing ingredient in robotics, the thing that makes human interaction with the world feel natural. While most robots avoid contact because it's unpredictable, Eggy is built for exactly that. The goal is to understand how humans interact with everyday objects. Wiping a spill with the right pressure, holding a glass without squeezing too hard, pressing a paper towel into a surface, gripping a milk carton, adjusting a slippery bottle, or pushing aside small objects on a countertop. To achieve this, Tangible Robotics uses sensor-equipped exoskeletons worn by humans. These devices capture not just motion, but tactile information, pressure, resistance, orientation, microcorrections, and physical feedback that cameras alone can't reveal. This tactile dataset becomes the foundation for Eggy's intelligence. The robot is designed not only to see but to feel, a philosophical stance that positions touch as the core of robotics rather than an optional enhancement. Do you think having full human-like hands makes Eggy more useful or more complex than it needs to be? Eggy's design reinforces this philosophy. The five-fingered hands look more like animated hands than mechanical tools. The rounded silhouette reduces intimidation and makes physical contact safer. The movements are slow, stable, and curious, mimicking the type of behavior audiences associate with friendly on-screen robots. And just like Memo, Eggy reflects a broader shift in robotics. The industry is recognizing the emotional and psychological importance of robot design in human environments. Memo and Eggy represent two different schools of thought. Memo focuses on simpler hands with smarter software, letting advanced models control high-precision tasks through learned human behavior. Eggy focuses on complex hands with tactile sensing, giving the robot human-like dexterity from the hardware level upward. One approach says intelligence can overcome mechanical limitations. The other says true intelligence requires human-like touch. Both are compelling. Both are ambitious. The next generation of robots won't look like machines. They'll look like companions,